I know that. That's why I was going to offer a hand.
That's right on my mind.
Yeah, because
layers of our air, or atmosphere, whatever you want to call it. Down here on Earth, where we would be, is the troposphere, the tropo layer, then the strato layer, meso layer, and then the thermo layer. And as you can see, thermo is cold, so I call that the ice area, and fire is hot, so that's where the fire would be. But you know, you would think at first that the moon would be in the meso layer, and that's what I thought. But I think they're both up here, and that's based on a video I just watched again, actually, from an amateur rocket launch, a Go Fast rocket that was launched in 2014. When you watch that video, the rocket takes off. Camera's pointing down. For some reason, cameras are always pointing down and never up, which would be nice if we could see what's going on when they're going up. But anyway. Camera's pointing down, rocket takes off, and pretty quickly the rocket starts spinning around like crazy. I mean, you can see the fins and you can see the ground spinning. It might make you dizzy if you stare at it too long. So the rocket's spinning as it's traveling up, and about 1 minute into the flight, it suddenly just stops. Rocket just stops, and that spinning stops. Everything just stops, and it just kind of sits there for a second.
yeah, copy. We are not getting telemetry from that last song. Please stand by.
And some people have suggested that it hit a dome that may be above us, but I thought at that velocity it would have been destroyed. So I didn't think much of it when I originally watched it, but I have to thank a guy named Jeff who just sent it to me again, because it really put some pieces together for what I was working on with this. And when you watch the video, the rocket just stops. And so I started looking up the stats. That rocket went over 3,500 miles per hour on that trip. Now, it might not have been going that fast when it stopped, but it was going a few thousand miles per hour at least, and it just, all that energy just suddenly, where did it go? Rockets don't have brakes. It literally stops, and I mean, the rotation keeps going a little bit, but all of that angular momentum from the rotation of the rocket and the linear momentum from flying up just stopped? No, it had to have hit something. what did it hit? If it hit a solid surface, the rocket would have been destroyed, and most likely the camera too, so we wouldn't have the footage, and obviously that's not the case. So when you start watching it, around that time, around a minute in, a few seconds later, the two stages separate. It's a two-stage rocket, it looks like, and you watch the bottom half of the rocket start to fall down, as you would expect. But then the upper half, the way the camera's mounted to it, starts spinning around, and very slowly it starts to fall back towards Earth. Very slowly. And you might think, well, I have it up here, the GoFast rocket got up to about 117 kilometers. And outer space is considered in the thermal layer. Once you cross into the thermal layers, technically you're in outer space. But what doesn't make sense is, just because you fly vertically into outer space doesn't mean that you're just going to float there. That's not how it works, based on the heliocentric model. If you watch Balls Out Physics Episode 3, I talked about how you have to have an orbital velocity, and these orbital velocities are incredibly fast. You have to be orbiting the Earth to resist the force pulling down on you, gravity, weight, whatever you want to call it, that pulls down on you. You have to do that. You have to do, basically, this string is gravity. Just to show this again, if you haven't seen that, you have to be moving at a high velocity to resist that force. That rocket went straight up, so it should have fallen straight back down. Now, just to see what the acceleration on that rocket should be, assuming very thin, almost no air up here, because that's what's supposed to be there, I did a calculation at 117 kilometers plus the radius of the Earth, and I found that the acceleration towards Earth, due to gravity, if you want to call it that, or due to weight, should be roughly 9.46 meters per second squared. That's not much. That rate is pretty close to the rate at sea level, which is 9.81 meters per second squared. So it should have basically done this, but it didn't. It stops, and then it just kind of slowly starts sinking, like it's in water or some type of liquid. That's what it looks like. If you really start watching it, the way those pieces are falling, if you get to about 2 minutes and 10 seconds in, you see the other stage, the lower half of the rocket, still slowly tumbling down like it's in water. According to mainstream science, as you get up in these layers, as the temperature goes up, as you get up in these layers, the pressure decreases. The pressure becomes almost nothing in the thermo layer and meso layer as well. But suddenly, it just kind of stops and then slowly starts sinking. What's going on here? Is there water there? There's some kind of liquid? Or some kind of very, very dense gas? Scriptures tell us that there is water up there. That's interesting. So the rocket just stops. Okay. Well, then there's the lunar wave that Crow 77 filmed in 2012.
So watch the lower left there, and I'm just going to run a straight slowed down view, 30%. If you've got sharp eyes, you'll see what we detected on a 60-inch monitor. Now look inside the circle. there's a pulse that goes from lower left to upper right, and in the next circle, the yellow one, there's a lateral sweep that goes from left to right straight across the screen. And this is all going on as the wave is starting at the bottom. So now look at the pulses backwards and forwards. That's backwards. This is forwards, coming from the lower left limb of the moon. You can see the pulses now that I've put filters on them, how they have a curved aspect to them. And if you've got sharp eyes, you'll see the sweep up above. Now what I'm going to show you now, we have talked about, and many sharp-eyed viewers have known that this was an important thing about this clip for a long time. Here comes the wave. Look at the dark underlined crater in the center of your screen. Watch how it's displaced, almost like you're looking through water. There goes the wave backwards, forwards, the wave hits the crater, displaces. This wave is displacing, as if you were looking through water, the entire image of the moon. Now, I've never taken the time to animate this. I have talked about it. There it is zoomed in. Now this is running at 30%. And I'm going to zoom out. There goes the wave to the top, and there's going to be another wave coming in from the bottom. Now I'm going to run this at 30%, so as the wave comes in, you can choose any landmark you want. Here comes the wave from the bottom to the top. Choose any little landmark you can see there and watch it be displaced. Now that round looking ring crater, forwards, backwards, and one more time forward, and I'll zoom out. And you can watch it go all the way to the top. Again, this is at 30% with quite a few filters like find edge and some other things, invert.
So you combine that with how this rocket behaves, and now I'm starting to think that I've seen enough evidence that I can actually write this right here. H2O. And this mesopause, as this area is called, where the temperature starts to increase as you cross into the thermal layer. I mean, rapidly increases up to 500 to 1500 degrees Celsius. There appears to be some water.
T-minus 90 seconds and counting. All systems are go. For about 90 seconds, we will launch a spatial discovery. T-minus 60 seconds and counting. We are transferring to orbital control power at this time. Discovery is now running off its 3 onboard fuel cells. Coming up on a go for all sequence start. Here on the go for auto sequence start. And we have a go for auto sequence start. Discovery's onboard computers are primary control of all the vehicle's critical functions. T-minus 17 seconds and counting. 15. all the vehicle's critical functions. T-minus 17 seconds and counting. 15.
Space may be the final frontier, but it's made in a Hollywood basement.
After 3 months of investigating on the flat Earth model, I finally found the 100% proof that the Earth is not a globe. And that's how I found it. This video is called Go Fast 2014. You can check out the full video, link is in the description. Basically, this video is a world record for the highest private rocket ever launched into space, and you can see the full flight without any cuts, filmed from 3 onboard cameras. The highest altitude is about 120 kilometers or 73 miles. That's so amazing. I always searched for a video like this. Unfortunately, it appears that the camera have fisheye lenses, however, the Earth still looks flat. I was watching this video at least 100 times and analyzed it frame by frame, hoping to find a proof for either the flat Earth or the globe Earth model. And then it hit me. The moon. You can clearly see the moon in these videos. Would that even be possible if the Earth is a globe? If I check the position of the moon at the date and time the video was taken, and it turns out that the moon would be underneath the curvature, it would prove that the Earth is not a globe. The video was shot on the 14th of July 2014. Unfortunately, I couldn't find the time the rocket was launched, and I would need a time to get the exact position of the moon. So I started investigating to find an approximate time when the rocket was launched. I found this video that was taken a few moments before the rocket was launched.
I did 2 circles around the rocket. Landed safely. Now the next morning I did a short flight just before the rocket launched.
Did you hear what he said? He said the next morning I did a short flight just before the rocket launched. That means the rocket was launched somewhere in the morning. It looks clear, the sun is already out, so it can't be that early in the morning. However, after the launch, they were flying in a helicopter to see where the rocket comes down. For a split second in this video, you can see a GPS device in the helicopter, which shows the time, and the time is 11:40. So the launch must be between approximately 8 o'clock at the morning and 11 AM. The rocket was launched in the Black Rock Desert in Nevada, USA. In July, Nevada's time zone is Pacific Daylight Time, which is UTC -7. Now, let's check out where the moon was at this time. I'm using timeanddate.com and trying to find where the moon was on the 14th of July from 15 o'clock UTC to 18 o'clock UTC. As you can see, by the time the rocket was launched, the moon was in this area, right over Australia. So, if the Earth is a globe, it would be impossible to see the moon from Nevada, because the moon would basically be on the other side of the globe. To imagine this better, there's this website called solarsystemscope.com, and you can also simulate a date and time here, and I also put the right date in. I'm not sure about the time zone here, so I just placed it so the moon would be above Australia, like we saw it on timeanddate.com. So if the Earth is a globe, and if this is our solar system, then tell me, how is it possible to see the moon, which would be here, from Nevada, USA, which is here? It's impossible. So if you say that the Earth is a globe, please tell me how this is possible.